Good morning, students. Today is the first class, the CDT1. The topic of discussion is Introduction to Electric Drives. So the objective of this day session is to introduce about the power semiconductor drives and a basic introduction to the electric drives. So at the end of this session, students will be able to know the fundamentals of electric drives. Yes, what are the various components that are required for electric drives? We have all discussed on the power electronics. In case of power electronics course, we have discussed that there are various power electronic devices and then power electronic converters. The advantage with these power electronic devices is that they can handle high voltage and currents, but can be controlled through their gate or base terminal with a very small electronic voltage and current levels. That made an advantage of power electronic devices to use in various practical applications. So we have discussed in power electronics course the various power electronic devices and relevant power electronic converters. So the advantage we have seen in case of power electronic converters is that they can be used for conversion of one supply to another output waveform, that is AC to DC or DC to AC. In addition, if there is no conversion of the voltage, but the output power can be controlled. So that is constant DC to variable DC, constant AC to variable AC, like this. With this advantage, we have seen that these power electronic converters are finding its applications. So, in industries such as cement mills, rolling mills, compressor pumps, fans, elevators, textile mills, blowers, rotary kilns. So, like this, you can name number of applications where power electronic converters are used. So, it means that they are used for controlling some of the electrical equipments. If you see, the common thing that is there in all these things is the electric motor. So the power electronic converters, they find the applications in controlling or operating high power motors that are controlled by power electronic drives. So in this subject, power semiconductor drives, we'll be discussing how these power electronic converters can be used to control the speed, torque, voltage, current of a motor, and that becomes what is called as an electric drive. Yeah. So in power electronics course, we have seen this block diagram. Like there is a power electronic converter. It takes some input, which can be raw electrical power, and you are getting a desired power, output electrical power in the form of required by the load. So as per the load requirement, you are generating the output power. Yes, the load requires 150 hertz frequency. The load requires 5 kilohertz frequency output waveform. The load requires 150 volts RMS value. Yes, whatever the values of output power or voltage is required, that is obtained by using this converter, and that is possible by what? Monitoring the actual output power, taking the input power, and then giving the reference. You are generating the control signals for the gate terminals or the base terminals, and then operating the converters. So our objective of analysis in power electronics course was limited to how to vary the output power, how to vary the output voltage. Accordingly, we have calculated the average voltage, average current, output power, input power, power factor. These terms we have calculated for various converters like controlled rectifiers, inverters, buck boost converters, cycloconverters, AC voltage regulators, like this. So these devices, these converters we have analyzed in power electronics course. Now, when you come to power semiconductor drives, this output power is connected to what load? Motor, electrical motor. So this electrical motor operation is to be controlled. Now we have to monitor at the output of the motor what is the speed, what is the torque that is produced, and hence control the total system to get the desired operation of the motor. And that motor is connected to some mechanical operation or mechanical process in the industry. So now comes what is electric drive. The system which is used for controlling the motion of an electrical machine is called an electrical drive. So now the electrical drive means that controlling the motion of an electrical machine. In other words, the drive which uses electric motor is called electrical drive. The electrical drive uses any of the prime movers. Some of the mechanical prime movers can also be used like diesel or a petrol engine, gas or steam turbines, steam engines, hydraulic motors, and electrical motors as a primary source of energy. So to run this motor, sometimes we may use the prime movers. So, but in addition, there will be an electrical motor which for which you are giving input as electrical input and you are getting mechanical output. So this prime mover supplies the mechanical energy to the drive for motion control. So that is what you are trying to do. So the purpose of electrical drive study is what there is an electrical motor which has its own characteristics, VI characteristics, no load characteristics like this, and that is connected to a particular load. This load is expecting some different requirements: sudden start, slow, reverse rotation. So then these type of operations should be able to meet through this motor. So how to do that one? For that, we'll make use of a suitable controller which can control the input power to the motor and hence the output power of the motor to match the load requirements. So that is the purpose of this electric drive or power semiconductor drives analysis. If you see the applications again, it looks like similar to power electronics, but we have to see that there is a motor in these applications. We study with PSD course. So it finds applications in industries as motor drive. So there can be a motor, and this motor is connected to the supply through a controller. So this is a controller which is made up of a power electronic converter and suitable control logic that is used. So this motor is shown here, which is connected through a controller, which is called as AC motor drive. So this is an AC motor, and this is a drive which consists of what? Power electronic converter and controller. Okay. So let us say AC or DC input is given and AC output is obtained, that is connected to the AC motor. So now if the motor is expecting the 50 hertz waveform, if the motor is expecting high frequency depending on its speed, the controller should be able to process the input and give the desired output to the motor. So that is the purpose of the drive or the total system. So in industry, there can be a large, high rated or high power motor which can be lifting uh, the product from and moving from one place to another place, or it can be the assembly of a car. So where the operations are going on. So there the motors have to move in a different directions, pick the load, place it, and all such operations should be controlled through the drive. Semiconductor drives will also find its applications in traction, like in trains, electric buses. Okay, then magnetic levitation trains, electric cars. So in such cases, there are motors that are there. So previously DC series motors were used. Nowadays, the AC motor, induction motors are used, and this has the power electronic converter, motor, and the controller, and hence this is the best example for the power semiconductor drive. To take the simple example like domestic applications, it can drives finds its applications in vacuum cleaners, air conditioners, refrigerators, where there is a motor and you need to have the different operations of the motor and control maybe automatically through a controller or microprocessor based, microcontroller based, Arduino based like this. So such a type of control is possible with the power semiconductor drives. So, dear students, we'll be using this textbook by G.K. Dubey, and the title of the book is Fundamentals of Electrical Drives. Please purchase this book, have your own book, and refer it. This subject, power semiconductor drives, completely depends on the content of this G.K. Dubey textbook. But there are still other reference books that you can refer by Vedam Subramaniam, V.K. Bose, P.S. Bimra, and N.K. Day and P.K. Sen. So these are the textbooks that are there. You can please refer those. So, in further understanding to know what is the real research work that is going on at the high end in this area, we can also refer IEEE journals, IEEE transactions on power electronics, IEEE transactions on industrial applications, IEEE transactions on industrial electronics, IEEE transactions on power quality. So these are the major IEEE transactions which deal with drives. Yes, we have come to the end of the session. So, in this introduction to electric drives, we have seen what is an electric drive and where it finds its applications. So, by now, you should be able to know about the fundamentals of electric drive. What is an electric drive and where it is used and what are its advantages. Yeah. So, you should be able to now define electrical drives, list the application areas where electrical drives are used. Please refer P.S. Bimra, Chapter 1, Section 1.1 for the introduction of the course. Thank you.